Good morning, Ms. Kiki and Ms. Lakshmi. So we are from Group 2 of Engineering Economics class, and we are here to present our final presentation deck. Let me introduce myself. My name is Aniqa Syabina Boer.
My name is Anaura Anitchka.
My name is Tsaqila Muvidah.
My name is Nafla Qonita.
My name is Alifia Putri.
So first of all, I'm going to be explaining about the executive summary or the company profile of the company that we chose to talk about today. So we chose the company of Whoosh High-Speed Rail project operated by PT KCIC. So Whoosh is Southeast Asia's first high-speed rail connecting Jakarta and Bandung with a maximum speed of 350 kilometers per hour. While the project represents major infrastructure modernization and attracts growing ridership, it continues to face financial and cost recovery challenges.
As you can see, this slide shows the main cash flows for the Whoosh project. Now this slide shows the main cash outflows of the project itself. The initial investment of 118.4 trillion rupiah occurs only in year 0 for infrastructure and systems. During operations, the biggest fixed costs are operational and maintenance, which is 1.5 trillion rupiah per year, and also debt service, which is 2 trillion per year in rupiah. It includes only interest. This means annual operating cash outflows is about 3.5 trillion rupiah even before profit or principal repayment. After we talk about the cash outflow, now we discuss about the inflow. The revenue is estimated based on realistic ridership and pricing behavior. We split passengers into two sections, weekdays and also weekends or holidays. Ticket revenue comes from premium economy, business class, and also first class. Using those assumptions, we estimated annual ticket revenue, where year 1 ticket revenue is 911 billion rupiah, and year 2 ticket revenue grows to 957 billion rupiah. Besides the ticket revenue, we also have a non-fare revenue. It is included but conservatively. Based on global railway benchmarks like MRT, PT KAI, or LRT, they have a non-fare revenue such as retail and station leasing, advertising, and also naming rights. We assume only 5% of the non-fare revenue as the income, lower than typical 10 to 20% to reflect the early stage development.
The next one is the final report analysis, our classification as a pioneer industry under a major fiscal advantage. Before, we faced the standard 20% of CIT and also the 11% of PPN. Right now, we achieve at 0% CIT tax holiday for 20 years, and also the PPN, we benefit from PPN exemption on imported capital goods.
These incentives significantly reduce the project's tax burden and help improve its financial viability. However, from an accounting perspective, losses incurred by KCIC are consolidated into PT KAI's financial statements. KAI recorded losses. These losses reduce cash availability for other rail services such as KRL, Intercity, LRT, and it creates broader financial risks across the national rail system.
I'm gonna talk about the rate of return analysis. Here's the project background and also the cash flow overview. The project is the Whoosh PT KCIC, and also we have the evaluated perspective. We have two evaluated perspectives. Here's the objective, and also I already calculated the project cash flow. As you can see, until year 30, net cash flow is negative for all operating years, and also no years produce positivity for the financial return. And here the ERR estimation using trial discount rate method. So here we have 3 trial method. So the first one is at the 7%, it's negative. At 5% also negative, and here I try in 1% is also negative as well. And here's we have the comparison between the operator and also the government. Since the present worth is always negative, so the project ERR is always below 0 and cannot be determined from the operator perspective.
Let's dive deeper into the benefit-cost analysis. Now, I have presented the benefits. The main user benefit comes from travel time savings, where average journey times are reduced from 120 to 150 minutes to 45 to 60 minutes. Additionally, the benefits comes from vehicle operating cost savings due to an assumed 40% modal shift from road to rail, as well as induced development effects such as transit-oriented development, tourism growth, and property value uplift around stations. Now, When all benefits are converted to present value, because we want to divide it by the investment, which is the present value, over 20 years at a 5% discount rate, the total quantified benefit reaches 14.9 trillion, showing that the project value is driven not only by revenue but also by substantial social and economic needs. Moving on to the disbenefits. The disbenefits here are the environmental and social impacts. However, let's take a look at its intangible impacts. It improves equity by enhancing accessibility and economic opportunities between Jakarta and Bandung.
So for this slide, we're looking at a simpler goal than full payback, which is operational break-even. If we look at the numbers, annual costs are around 3.5 trillion rupiah, while current revenue is only about 968 billion rupiah in year 1. So clearly, we're still in a deficit position. We need roughly 14.3 to 14.9 million passengers per year, or approximately 39,000 passengers per day, just to cover the annual cost. Moving to payback, the situation is even more challenging because annual net cash flow is still negative. We're not accumulating positive cash inflows over time. In theory, if net cash flows never becomes positive, the payback period is undefined or effectively infinite. So the project cannot pay back its initial investment under current conditions. So the key takeaway here is that even without considering principal repayment, the project would need a massive increase in ridership just to break even annually.
Next, I'm going to explain about the depreciation methods, which is straight line method and also the DDB. So starting with the straight line method, depreciation is calculated using this formula. The result is in a constant annual depreciation of 0.5328 trillion per year. Because the depreciation expense is the same every year, the book value decreases linearly until it reaches the salvage value at the end of year 20. On the right side is the double declining balance, or the DDB method, which is an accelerated depreciation method. Under DDB, depreciation is higher in the early years and decreases over time because it is applied in the beginning book value of each year.
Next up is the after-tax economic analysis. So basically, this slide explains how before and after-tax economic analysis are calculated and why their values are different. Based on the calculation table and the provided formulas, the before-tax cash flow is 544 billion in year 1 and 540 billion in year 2. As a result, the after-tax cash flow is significantly lower than the before-tax cash flow, amounting to 11.2 billion in year 1 and 7.8 billion in year 2. So in conclusion, this table shows that even with a 0% tax rate for SOEs or private concessionaires due to losses or tax incentives, the after-tax cash flow can still be significantly lower than before-tax cash flow, mainly because of the financing structure. So the big question is, how do tax, depreciation, and loan interest influence NPW or IRR? Tax reduces after-tax cash flow, which directly lowers NPW and IRR. A higher tax rate means less cash retained by the project. However, if the project has tax holidays or operates at a loss, tax payable may be zero, so taxes do not materially affect NPW or IRR. As for depreciation, it is a non-cash expense that lowers taxable income. This creates a tax shield that increases after-tax cash flow and improves NPW or IRR. For loan interest, it reduces NPW or IRR through large annual cash outflows.
So that's all from us.
Thank you!